Hi, I'm Pedro Nunes. We're Group 5, and this is our presentation for the Poisson Ratio lab. For the introduction, the Poisson Ratio is a simple random statistical distribution as a counting distribution used to predict the number of occurrences of the event with a certain interval. The Poisson Ratio distribution provides a procedure for estimating the randomness in the traffic stream, like comparing with the field measured in theoretical values. It also can be demonstrated a statistical distribution. For the objective of the lab, for the Poisson ratio is to find the probability of a few events occurring in the fixed interval of the time, with the find of the event happen with the no average rate independently of the time. The data collection was in the eastbound direction of the San Marietta Parkway at the KSU West main entrance. The collection was made on February 6 at time of 4:30 to 6 o'clock. The location, if you guys can see, that's a perspective 3, and then we use the group plane 1 to collect our data for this lab. This is our effort statement.
So for the data collected, we put a stopwatch timer every 20 seconds and counted the number of vehicles that passed the red line shown on the screen. We focus on the lane group headed east towards I-75 circled in red as seen on the diagram on the top left. Here we have the calculations for total vehicles, observed probability, cumulative probability, computed Poisson, and cumulative Poisson.
So for the null hypothesis, we said that the arrival rate of the traffic on the eastbound approach of the study intersection will follow a Poisson distribution. And for the alternative hypothesis, we said that the arrival rate of the traffic at the eastbound approach of the study intersection will not follow the pattern of a Poisson distribution. On the next few slides, we have our results shown. The first 3 columns here on the table, the data was collected from the traffic counts videos that we collected at the beginning of the semester. So from that, we obtained the number of vehicles, the observed vehicles, and the total vehicles. The data in these 3 columns were then used to calculate the data that is shown in the last 4 columns of this table. And the average arrival rate was calculated to be 2.26. Our data summary is shown on screen. The number of vehicles, observed frequency, and computed frequency were used to determine the chi-squared of our collected data, as well as compare that to the critical value of chi-squared at a 0.05 critical value interval. The chi-squared for the data summary that's shown on screen was found to be 9.1. The critical value chi-squared was 9.488, and that was based off a degree of freedom of 4, and that was determined by calculating 11 minus 7. And in this case, since our calculated chi-squared was found to be less than the chi-squared critical value, the Poisson distribution ended up being an estimation of the distribution of arrival rates. However, we'll discuss in the discussion portion if we believe that it is truly representative of our pattern of data. Based off of just the chi-square values, the null hypothesis is accepted.
So as you can see from the results, the Poisson equation is not a good indicator for the behavior of this intersection. Specifically, I will compare some of the numbers on the table that we saw earlier. So for the first row and the fifth row, you can see that the observed probability and the computed Poisson are drastically different. Sometimes they're twice or 3 times as more or less. The cumulative probability and the cumulative Poisson distribution also differs greatly. With that said, the Poisson equation for this intersection cannot be used to predict the minimum green time, does not show that the statistical functions are useful in traffic data. However, we should collect more data just to be sure, since this was only a 1-day event over 3 hours. I would suggest doing this every day during the same time for Monday through Thursday over a few weeks to get some more data to see if this Poisson equation can actually work. So for our conclusion, the Poisson ratio, no good. We do prefer the observation method for this intersection. However, we should get more data. And here are references. Thank you.